Hey guys, Tiny Maths here again with another video, helping you reach your goals to understanding maths in small steps, one step at a time. In today's video, we're going to prove that all the angles in a triangle add up to 180 degrees. In order to understand this proof, you will need to know two things. Firstly, you need to know how to find alternate angles. If you're unsure about how to do that, or you need a reminder, I've linked to one of my other videos at the end of today's lesson. That video discusses the basics of alternate and corresponding angles. So once you finish here, you can check out that video for a quick reminder of how alternate and corresponding angles work. The other thing you need to know, and I'm assuming you already know it, is that the sum of angles on a straight line is 180 degrees. Why this is important will become apparent towards the end of our proof. Okay, here's a triangle with internal angles A, B and C. We don't know the value of any of these angles, but that's not important. We just need to prove that all three of them add up to 180 degrees. But before we can do this, I need to make a few alterations to this triangle. By the way, if you stick around to the end of the video, I'll be explaining how you can use a triangle with its 180 degrees to work out the internal angles of any polygon. In the meantime, don't forget to like the video and subscribe so we can reach more maths students with Tiny Maths videos. So let's make these alterations. The first thing I'm going to do is extend the left edge of the triangle at both ends, and I'll do this to the right edge as well. Then I'm going to extend the bottom edge of the triangle in both directions. And finally, I'm going to draw a horizontal line through the tip of the triangle. This line is parallel to the bottom edge of the triangle which we just extended. Now notice that both the extended edges of the triangle cut through the upper and lower horizontal lines that are parallel to each other. So you can see this clearly, I'll separate things a bit. First, the left edge of the triangle cutting through the parallel lines, then the right triangle edge as it cuts through the parallel lines. Also note, between the upper horizontal line and the triangle right and left edges, there are two angles, one either side of the angle A, which is inside the triangle. Those two angles are outside of the triangle. Let's colour the one to the left of the angle A red and the one to the right of the angle A green. So we can now start showing how the angles A, B and C actually add up to 180 degrees, and we'll do this by using our knowledge of alternate angles. We're going to look for the alternate angles of the angles B and C that are within the triangle. I'd like you to look at the angle B that's inside the triangle. Note where the alternate angle of B is. Well, let's separate things a bit again. Now can you see where the alternate angle is? Yes, it's the red angle on the left side of the angle A. This means that the red angle is the same as B because it is the alternate angle of B. Now take a look at the angle C inside the triangle. Can you spot the alternate angle to C? Again, let's separate things a bit. Now can you see the alternate angle of C? Yes, it's the green angle, the one to the right of the A angle in the triangle. So the green angle is the alternate angle of C and therefore has the same value of the angle C. Now let's take this information we have, that is, red equals B and green equals C. We can use this information to change our coloured angles to the letters that they are equal to. So red becomes B and green becomes C. Well, look at what we now have. The coloured angles that were either side of the angle A, the one that's within the triangle, have now been rewritten with the alternate angles of the same size, and now they are angles B and C. If you haven't already noticed, we have three angles on a straight line. The angle A in the middle and B and C are either side of it, all three of them on a straight line. And now here's why knowing the sum of angles on a straight line is 180 degrees is so important. You can clearly see that the angles A, B and C form one big angle across the upper horizontal line, or straight line. They fit exactly onto the straight line. And since the sum of angles on a straight line add up to 180 degrees, that means that the angles A, B and C add up to 180 degrees. But look, the angles within the triangle are also A, B and C. So that means that those internal angles add up to 180 degrees. So there's the proof. A plus B plus C equals 180 degrees. So yes, the angles of a triangle do add up to 180 degrees, and that's our proof done. Now that we know for certain that the internal angles of a triangle add up to 180 degrees, we can discuss how this helps us work out the angles of other polygons. For example, a square is made up of two triangles, so its internal angles must add up to 2 times 180 degrees, which is 360 degrees. A pentagon is made up of three triangles, so its internal angles must add up to 3 times 180 degrees, which is 540 degrees. A hexagon is made up of four triangles, so its internal angles are made up of 4 times 180 degrees, which is 720 degrees. Even odd-shaped pentagon angles can be calculated by using triangles. This one, for example, is made up of 5 triangles, so its internal angles add up to 5 times 180 degrees, which is 900 degrees. And because we just proved the angles of a triangle absolutely must add up to 180 degrees, you have a guaranteed way of showing what the internal angles of any polygon is. So now you know how we are so sure that the angles of a triangle add up to 180 degrees, because we've just proved it. If you need to refresh your memory on the basics of alternate and corresponding angles, follow this link that's coming up on screen. I also recommend watching my video Finding Angles in a Polygon yn-2 times 180 degrees. It goes into a bit more detail about using triangles to find angles of polygons, and I explain why the formula n-2 times 180 degrees works. It's related to the angles in a triangle. Well, that's it for now. Thanks for watching. I'll see you next time.